Let's look at part 8 of ML Basics. In this video, we will discuss about sample and population, train and test split, cross-validation, normal distribution, and cost function. Population is the whole group and sample is a small part of it. Example, all students in the school is population and students in one class is sample. ML often uses samples because it's difficult to collect data for the entire population. Next, train and test split. We divide data into training and testing parts. Training data teaches the model and testing data checks if the model learned correctly. Example, practice questions is training and final exam is testing. Next is cross-validation. Instead of one test, we split data into many small parts and test multiple times. Example, a student gives 5 small practice tests instead of one big exam to check real understanding. ML uses cross-validation for fair evaluation. Normal distribution. It's a bell-shaped curve most data follows. Example, in a class most students score around average. Few get very high or very low marks. ML and statistics use this curve often to understand data. Cost function, which is also called as loss function. A cost function tells how wrong the model's predictions are. Let's take one more simple example of linear regression for cost function. Imagine we want to predict a student's exam score based on hours studied. The data accumulated is that the student A has studied 2 hours and the actual score is 50, and the student B has studied for 4 hours and the actual score is 80. But what the model predicts that the initial guess from the model is, for 2 hours the predicted marks are 60 and for 4 hours of study the predicted marks are 70. Now the error is calculated as the difference between predicted and actual. For student A, the predicted was 60 and the actual score was 50, so the calculation is the difference between 2, which is 10. And for student B, it is 70 minus 80, which is minus 10. The cost function, which is also called as mean square error, is calculated as per the formula given. The cost function comes out to be 100, meaning the model's predictions are quite off, and training will adjust the model to reduce this number.